Ladies and gentlemen, welcome to my shop. Welcome to my channel. My name is Keith and I'm your host. Before we get started, class, how about the Pledge of Allegiance?
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, for liberty and justice for all. Amen.
Alright, today we got a whole piece of aluminum here. This is an expansion tank on diesel on one of my customers' boats. And this is the kind of job that make me question the faith my customers have in me and my talents that I have. All right, this isn't the end we're going to work on. This over here is, I'm going to turn it upside down because it'll lay here much better. This port is what's in question on this job. And I got to pull out this O-ring in here. All right, and it's covered up with silicone, and there's silicone wiped all around in here because it was a last resort type of fix, getting the motor back together and in the boat and running. And this is a sleeve that joins this piece with the block. All right, so we have porosity in the aluminum all around underneath that O-ring, and the surface around actually holding the diameter here, which is supposed to be a slip fit, but it's supposed to be close, and the O-ring groove is supposed to be crisp and clean. We're going to make an attempt to skim clean this in the machine. We're going to machine it instead of get in there and grind it and O-ring, and try to clean out the groove. I'm going to bore in until we have this outside removed and we're down there to where I got a clean bore of down to into the O-ring surface. Skim down to where there's a shoulder. There's a shoulder in the back here. And then when we have good clean aluminum to our face, then we'll go ahead and we'll weld build this up and then remachine this pocket in here and rebore that O-ring groove and stuff like that. So we're going to be testing out a few of the tools that we actually have and our capabilities of coming in and plunging. It'd be like an inside parting. Like you're parting an outside diameter. Well, we're going to be doing a similar thing on the inside with a boring head. How are we going to hold this in the mill? Because we're going to put it in the mill over there. There's a machine flat surface here, but these elbows are in the way, so we're going to go ahead and we're going to remove these. And we're lucky that somebody has pulled these off lately, because all these fasteners come out fine. If I had an issue with that, then I would have left them and I would have went about this some other way. But we have a good flat surface, so we're just going to toe clamp this down and put this at a right angle to the K&T's spindle coming out. They look the same, but we're going to go ahead and mark these. We're going to go left, right. Just the way we wrote those letters on there, we'll be able to hold this thing in place with those sticking out in that position. They only have a 3-hole pattern. They only can go one way, left and right. Okay, we're going to get a putty knife in there. Alright, I'm going to scrape off those gaskets. Alright, we lightly file, put the file across those faces to remove the rest of the gasket material. No rocky. So this plane right here is the same flatness as this face right here. And we'll double check that with a square. And it is. Alright, now we just need to get blocks here and toe clamp this down on both sides here. Indicate basically this rough flat face right here so we know that we're 90 to it. And then come in with our boring head and then start working those surfaces. Our longest studs in our kit allow threads to stick up here from the groove there, and all we needed was a block to actually hold our step block a little higher than needed so we can get the toe or the finger going down on the top here. Okay, same thing on this side. I like that. We're with this surface right here. This is an added piece on the end, so we got to stay with this face of this casting. I like that. Okay, so now the base machine surface is flat with the table, and this is flat with the edge of the table. So we should be square enough to go ahead and create our bore. And that snout only sticks in a little tiny bit, and it's not hard locating this whole part. So we're going to be able to put this back in, put it in here, and then roughly zero in our hole and bore that to finished size with no issues. Now we want to zero the spindle up with this hole. Okay, we'll pull out the drill chuck here. And we're going to put our number 4 Morris taper in, and we're going to put our bell center from our lathe in here. Okay, because we're gonna eyeball this true. This thing is so pitted in porosity that you're not gonna get an indicator to go around there smooth, and why drive yourself crazy right there? We're going to zero this in the best that we can by eyeball. And then we're going to put a vise stop right against the side here so that when this is on the table, flush with the table, and all the way over to this position, it's going to be lined up with exactly where we're boring it right now. Okay, we got the feel here, and we use this just like a center finder, and we got it loose. All right, and we can go slightly up. It's looser, more, looser, more, looser. Okay, now it's starting to get tight again. We'll back it off about half of that distance. We're going to go to this side. We're going to go to that side. Okay, that's very, very short to go here. So this hole is oblong as far as the contact area against the circular position on the taper of the cone. Right there. We're going to consider that 0. All right, we're going to put our really sweet mill stop here. Colin Chapette, one of our friends in Canada, made this for us a while back. All right, that's gonna be close enough, and this is not curved enough to really matter more than a couple thousandths by relocating. Of course, we're just going by scale off of this surface, and we're going to go off of this fixed point right here. So there's locating this in 3 axes: the flatness of the table, the face of the edge of the table, and an end stop. We got our boring head in here. We took out our long bar, and we're going to run something a little shorter, even if we have to make something. We're going to get our full travel backed up on the table, but it looks like we have enough throw anyway. We're only going in an inch or so, so it looks like we have more than an inch in here. All right, we went searching. We found one of our lights that used to be over facing down on the Bridgeport over in the other shop. I've got a high-speed tool bit set in here, and it looks fairly sharp. We're not bothering with that at this time, and we're gonna feed this in to where we're inside the bore. Then I'm gonna adjust the tool bit to just start touching that outside edge there. Okay, it's touching over here, not quite touching there, but it is real close. We're gonna go ahead and go inside the O-ring groove to the back side. We want to check the same thing. If it looks like we're rubbing on the back side of it there as well, then we may move this over slightly just to get it to what we feel might be a more true round or centered hole. Okay, we're inside that area there. Let's sweep it over. See, we're making contact there. We're making contact all the way around. So I'm going to take it that centering we did on the outside is perfect. All right, I'm going to just give myself a little bit skosh on there, because we're basically going in to make the first contact with that back wall, and we want to establish that depth that it would hold that sleeve in place. That's what it basically does. Alright, we can speed this up a little bit for the aluminum. We don't have to hold back on that. Okay, we're into that O-ring groove now. Started on the other side. Okay, we're up against that back wall. I'm taking a little bit till I see some clean material there. All right, looks clean right now. I'm gonna back out. All right, let's get the vacuum here. Here's the very first skim, and here's a look down at it, underneath it, and then from your side in their detail. Still some silicone rubber stuck in there, and you can see some of the pockets where the electrolysis has eaten into the aluminum. All right, we're going to take like another 50 thousandths per side off for the next cut. All right, this is going to be 50 thousandths total, 25 per side. I'm still feeding it by hand. The cut still looks real chalky. It is cast aluminum, but it has a lot of corrosion in it. All right, we're on the inside as well. This time when I get to the bottom, I'm going to stop and set my dial. There we go. All right, it almost looks clean enough at the very inside, but we're going to take another cut there. This is another 25 thousandths per side. Alright, now let's get to the other side of that O-ring. There we go. That's really sounding good on the deep there. Okay, and there we come, right there. That looks pretty darn good in there. Alright, I don't think we're going to take any more down in the very bottom there, but we're going to start opening up this outer lip into that O-ring groove. We need to cut this until we're square down to the O-ring groove and cleaning that up. The bottom of the O-ring groove is probably the most important part of this. You can start seeing some of the silicone rubber that was down in the groove there starting to break free. Okay, we're going to be resetting a new zero stop once we're comfortable with that depth we're going to be making. Okay, that looks like we're pretty close right there. I think I'm going to set a zero there. We're just going right into our next cut. Looks like we're starting to skim the OD or the root of the O-ring groove right there. Alright, we're coming across. There's our zero. Alright, we can see there's just a skosh of corrosion down there in the bottom of that O-ring groove that we started skimming round in there. This is another 25 thousandths cut here. It should be our last cut here, just because we're getting thin over here on this area right here. And I mean, I can build up that wall as well, and if this folds in here, we'll be just adding more material to form this outside and inside. And here we go. That's really looking like some good material there. It's coming off in a good chip. We're not hearing so much of that crispy, dry stuff. We might hear a little bit of it right in here because we're at the O-ring groove now. Where I'm staring, the porosity is clearing up. A couple little tiny spots, but I think none of it's going to be bad enough we can't really deal with it. I'm going a little bit more on that face. There we go. Okay, that setup can just stay right there. That looks pretty darn clean in there. Let's find that sleeve. Okay, here's the sleeve intended. We'll rotary burr around this outside edge right here, and let's go weld that up. It's pretty nice. We got a couple sheets up here that we're getting ready to go into the plasma cutter and make a few projects on it. But it gives us a nice big bench, and with those elbows off of this piece, it stands up real nice, and I think we're just gonna work that piece right around. Now I've got the torch here. We're going to preheat this casting. It'll take and maybe bake out a little bit of the chemicals that might have been in this area. Other than that, it kind of lets the welding go on without expanding and contracting real quick on it. All right, let's see how the rod melts in with the casting here. It is a little bit dirty down on the back side, and that's wanting to suck around on the outside of it, but I think we're going to be okay. There is a heat sensor right there. Try to keep that away from it. This clamp is in my way. There we go. A little better. eliminate the big ball on the end of my tungsten here. Every once in a while, a piece of silicone rubber that's been squished out on the backside down there kind of like flares up into a little smoke ball. All right, we've got past that really tough spot there. At least the first one we came across. Contaminated our tungsten a little bit, so we're going to clean and grind that. Okay, I just turned it up to show you, but right in along that edge where that bead is sitting on top of that little ledge right there. We're going to take a rotary burr and we're going to go around this till we clean that, and then we're going to take and roll this over onto the clean area and seal that last lip down in there, because that's where the shoulder, where the seal is going to go in and set against that. We need to have that as secure as possible. The best therapy after you spend a couple hours working on shit metals, to grab a big chunk of good aluminum, run a couple beads, and remind yourself that you can weld. You're half decent welder, and the reason why this looks like this is because of the shit metal you're working on, not anything that you know or your experience.